Hello everybody. This is lesson 17 of the lecture International Economics. I will discuss slide 28 to 49 of chapter 3, Currency Politics. In this lesson I will talk about the influence of differences in interest rates on the exchange rate. Since investment in interest-bearing assets takes always place over time, we have to take an intertemporal perspective on foreign exchange markets now. So far, we have discussed the so-called spot exchange market. This is the market where different currencies are traded against each other today. And today means on the spot. On the spot market, an agreement between buyer and seller is made today, and the currency is delivered by the seller to the buyer today. So everything takes place today on the spot. But there are also different foreign exchange markets called forward exchange markets, where foreign exchange is traded for future points in time. On these markets, the exchange rate at which the currencies are exchanged against each other is fixed today, but the exchange itself takes place at a future point in time, for example 3 months from now. On such a forward exchange market, we can make sure to be able to convert euro into dollar 3 months from now at an exchange rate which is fixed today, if we agree in a so-called forward contract with maturity of 3 months. We can find again the accurate relation between the exchange rate and the interest rate of domestic and foreign assets with the help of a numerical experiment. Where would you invest your money at the following exchange and interest rates? The interest rate for a fixed rate bond denominated in euro with a maturity of 1 year is 10%. At the same time, the interest rate for a fixed rate bond denominated in dollar with a maturity of also 1 year is 6%. The spot market exchange rate is $1 per euro, and the forward market exchange rate paid in 1 year is $0.92 per euro. To find out whether an investment in a euro bond or whether an investment in a dollar bond is more profitable, we have to calculate the revenue of these investments in the same currency. For an investment in a euro bond, this is quite simple. Let's assume we invest €1, so after 1 year our return will be €1 times the interest factor. If you fill in the euro interest rate of 10%, this yields a revenue of €1.1 after 1 year. If you want to invest €1 in a dollar bond, we first must convert this euro with the help of the spot exchange rate into dollar. The resulting amount of dollar can then be invested in the dollar bond at the dollar interest rate. Now we have to take care that we receive at the end of the year a dollar interest payment as a revenue, not a euro payment. Therefore, we have to convert this dollar payment into euro with the help of the forward exchange rate. We know the forward exchange rate 1 year in advance. Therefore, we can be sure to repatriate our dollar returns into euro at this forward exchange rate, no matter what the spot exchange rate will be 1 year from now. All we have to do is agree in a forward contract, for example, as offered by a commercial bank or a forward exchange market. Now we can fill in the numbers from our table in this formula for the spot exchange rate $1 per euro, for the dollar interest rate 6%, and for the forward exchange rate $0.92. Then we can calculate the numerical value of the dollar investment, which equals in this case 1.15 euro. This means an investment in the dollar area is more profitable than an investment in the euro area, even though the interest rate in the euro area is higher than the interest rate in the dollar area. The reason is the forward exchange rate of $0.92 per euro, which implies an appreciation of the dollar against the euro compared to the spot exchange rate of $1 per euro. Since the return of a dollar bond investment is higher than the return of a euro bond investment, people want to invest their money only in dollar bonds. As a result, the demand for dollar grows, which means at the same time the supply of euro grows. As a result, the euro depreciates against the dollar. And this means that a spot exchange rate of $1 per euro cannot be the equilibrium exchange rate. So let's therefore try a somewhat lower exchange rate. For example, let's take an exchange rate on the spot market of $0.9 for 1 euro. So now we have to do the same calculations again with the lower spot exchange rate of only $0.9 per euro. We have to multiply this with the dollar interest rate factor with an interest rate of 6%. And then we have to repatriate the resulting dollar payment into euro with the help of the forward exchange rate of $0.92 per euro. The resulting return in euro is then 1.04 euro. The result shows now the revenue of a dollar investment is with 1.04 euro clearly lower than the revenue of a euro investment, where the revenue is 1.1 euro. Since the return of a dollar bond investment is lower than the return of a euro bond investment, people want to invest now their money in euro bonds. As a result, the demand for euro grows, which means at the same time the supply of dollar grows. As a result, the euro appreciates against the dollar. But this means that a spot exchange rate of 0.9 dollar per euro cannot be the equilibrium exchange rate either. This means neither the high exchange rate of $1 per euro for our first example can be the equilibrium exchange rate, nor the low exchange rate of $0.9 per euro of our second example can be the equilibrium exchange rate. But we can conclude that the equilibrium exchange rate must lie somewhere in between $1 per euro and $0.9 per euro. Instead of undertaking more numerical trials, we can also calculate the equilibrium value of the spot exchange rate directly. At what spot exchange rate would you be indifferent between an investment in euro and dollar bonds? To find the value of this exchange rate, we can set up an equation that equilibrates the euro return with the dollar return and leave the spot market exchange rate as an unknown variable. And then all we have to do is simply to solve for the spot market exchange rate. In the same way we have this already done for the purchasing power parity relationship. So let's do this now. We can use, of course, the same equation as before, only we now fill in an unknown variable. We take our symbol for the spot exchange rate, E is the index dollar per euro, and then we multiply this with the dollar interest factor and divide the result over the forward exchange rate. So this is now one equation with one unknown variable, and in this case it is simple to solve this equation for the unknown variable. So what we have to do is we have to divide both sides of the equation by the dollar interest factor. Then the dollar interest factor disappears on the right side, reappears on the left side, and then we multiply both sides of the equation with the forward market exchange rate. Then this exchange rate disappears on the right side and reappears on the left side. So now we have found the solution for our equilibrium spot exchange rate. The value is $0.9547 per euro. This is the exchange rate where euro and dollar bonds have an equal return. So there is no incentive for the participants of financial markets to demand more euro or demand more dollar. So if everything else would stay unchanged, the spot market equilibrium exchange rate would also stay unchanged. This example demonstrates that an equilibrium on the exchange market can only exist if interest and exchange rates are such that investors are indifferent between investing money at home or on foreign capital markets. This relationship is called interest parity. The corresponding equation is called the interest parity equation. Let's review this equation. In an equilibrium on the spot exchange market, the following equation must hold. The return on investment of euro in a eurobond must be equal to the return of the same amount of euro in a dollar bond. We first have to convert our euro into dollar with the help of the spot exchange rate. Then we can invest the resulting amount of dollar in the dollar bond at the dollar interest rate. And then we have to recalculate the value of the resulting amount of dollar into euro with the help of the forward exchange rate. This is what we have called the interest parity equation. If this equation is solved for the spot exchange rate, the resulting formula shows the influence of the other variables on the spot exchange rate. As we have already seen, to do this we have to divide the equation, both sides of the equation, by the dollar interest factor, and then we have to multiply both sides of the equation with the forward exchange rate. The resulting formula is this one here. It shows that an increase in the domestic interest rate will cause an appreciation of the domestic currency if all other variables stay unchanged. The economic explanation for this relationship is if the domestic interest rates increases and everything else stays constant, euro bonds offer a higher return than dollar bonds. Consequently, investors will want to buy euro bonds and sell dollar bonds. To do so, they have to exchange dollar against euro so that the demand for euro grows and the supply of dollar increases, such that finally the euro appreciates against the dollar. To the contrary, an increase in the foreign interest rate will cause a depreciation of the domestic currency if all other variables stay constant. The economic explanation for this mechanism is now if foreign interest rates increase and everything else stays constant, dollar bonds will offer a higher return than euro bonds. Consequently, investors will now want to buy dollar bonds and sell euro bonds. To do so, they have to exchange euro against dollar so that the demand for dollar grows and the supply of euro increases and the euro depreciates against the dollar. So the interest parity equation helps us to understand how changes in interest rates affect the exchange rate on the spot market. But so far, our results are completely theoretical. The question is whether the interest parity equation is also empirically reliable. Transaction costs are less important on capital market since, for example, capital international market transactions cause typically no transportation costs. because these transactions are registered today by online booking systems. So from this point of view, the interest parity equation should hold better than the purchasing power parity equation, where transportation costs played an important role. A lot of empirical tests with regard to this question have been undertaken. I would like to show the results of a test based on a simple diagram. This test was undertaken and published by the German Bundesbank. To understand this diagram, we have to modify the interest parity equation in the following way. We divide both sides of the equation by the euro interest factor, such that it disappears on the left side and reappears here on the right side. Then we divide the equation by the spot market exchange rate, such that the spot market exchange rate disappears on the right side and reappears here on the left side. So the interest parity equation implies that the forward exchange rate over the spot market exchange rate equals the ratio of the dollar interest factor over the euro interest factor. If this equation holds, this equation must also hold. Now it is quite simple to check for the validity of the interest parity equation with the help of a simple diagram. This diagram measures the exchange ratio on the y-axis and the interest factor ratio on the x-axis. The equation implies that all observation points should lie on the 45-degree line, this black line here. The 45-degree line is the bisectrix of this 90-degree angle of the diagram axis. It mirrors all points on the x-axis to the same points on the y-axis. For example, if we start on the x-axis at a value of 1.0 and draw a vertical line to the 45-degree line, then the 45-degree line reflects the same value to the y-axis, 1.0. Or if we start with an x value of, let's say, 0.996, draw a vertical line to the 45-degree line, then the 45-degree line reflects the same value to the y-axis, 0.996. The blue observation points calculated by the Bundesbank with the help of the economic data for the interest factors and the exchange rate indicate that most of the time these points lie in fact quite close to the 45-degree line. The small observations around here or here can be explained by the existence of comparatively small transaction costs like bank fees and brokerage. Stronger deviations are quite seldom to observe. If we take one such outlier, for example this one, we can see that the exchange rate ratio is too high for the given interest factor ratio. Such a situation implies a possibility for a profitable deal. For example, in this case, taking a dollar credit and investing the money in euro bonds, where the interest rate is too high for an equilibrium. This will then cause the dollar interest rate to grow and the euro interest rate to fall. And the spot exchange rate will tend to appreciate. As a result, these kind of transactions will cause a movement back to the 45-degree line. Since thousands of investors continuously scan the markets with very fast computers to detect such possibilities for a riskless profit, these type of corrections take place quite fast in reality, such that most of the observation points lie in fact quite close to the 45-degree line. To sum up, the diagram shows that the interest parity equation performs most of the time quite good from an empirical point of view. So it is something we can rely on. To close this lesson, let's transfer our considerations on a market diagram of the foreign exchange market. What does the interest parity equation imply for the slope of the euro demand and the euro supply curve of the foreign exchange market? The euro demand curve has a negative slope because the cheaper the euro, the cheaper are bonds from the euro area for foreigners, which implies a higher return measured in foreign currency. So if Americans want to buy more euro bonds, they have to convert more dollar into euro. So as a result, the euro demand increases as the euro gets cheaper. The euro supply curve has a positive slope because the more expensive the euro is, the more dollars are paid for 1 euro. Hence, the cheaper are US bonds for residents of the euro area. This implies higher return for foreign bonds measured in euro. If Europeans want to buy more American bonds, they have to exchange more euros into dollars. As a result, the euro supply increases when the dollar becomes more expensive. Let's measure the exchange rate again on the y-axis and the volume of traded euros on the x-axis of the foreign exchange market. As we have just discussed, the euro demand curve has the usual negative slope, since the more euro is paid for $1, the cheaper euro assets get, so that the return on an investment in euro assets grows. The euro supply curve has the usual positive slope, since the more euro is paid for $1, the cheaper euro assets get, such that the return on an investment in euro assets grows. The intersection point of both curves provide the equilibrium exchange rate. What happens now to the equilibrium exchange rate if the euro interest rate grows? Interest rates do not appear on the y-axis, hence they are shift parameters. if interest rates in the euro area grow, Americans will try to invest more money in the euro area since they receive higher interest payments. Consequently, the demand curve for euro shifts upward or to the right. Since less Europeans will now want to invest money in the USA because US interest rates are now less attractive as European interest rates. So Europeans demand less dollar and therefore supply less euro to the foreign exchange market. Consequently, the euro supply curve shifts to the left. As a result, the euro appreciates against the dollar, as the new intersection point here shows. So this graphical analysis comes basically to the same result as the interest parity equation which we have derived before, which also shows that an increase in the euro interest rate causes an appreciation of the spot exchange rate of the euro. To sum up, trade in goods and trade in financial securities affect the spot exchange market basically in the same way. Both kinds of trade have the consequence that supply and demand curves on the spot exchange market have the standard slopes, as well known from microeconomics. The more dollar is paid for 1 euro, the more US goods are cheaper than euro goods, and hence the more euro is supplied in exchange for dollar. The less dollar has to be paid for 1 euro, the more euro goods are cheaper than dollar goods, and hence the more euro is demanded in exchange for dollar. The more dollar is paid for 1 euro, the cheaper US assets get, so that the return on investment in US assets grows. Hence, the more euro is supplied in exchange for dollar. The more euro is paid for $1, the cheaper euro assets get, so that the return on investment in euro assets grows, and hence the more euro is asked for in exchange for dollar. So much for this lecture. In the next lesson, we will analyze the influence of central banks on the exchange rate of their currency.